We are now going to talk about sets. Understanding sets is going to be extremely straightforward and simple. So let's dive into it right away. Usually in mathematics, whenever we represent a set, we represent it in second brackets. So if you know the mathematical concept of sets, it is that it contains unique elements. There can be no duplicates. And that is exactly what the set interface in Java tries to model. The set interface extends the collection interface. The iterable interface is extended by collection. So everything that we saw in iterable, which is using an enhanced for loop to iterate over the elements of a collection, and also the different methods that we saw in collection, such as contains, equals, is empty, size, and all of the other methods, are present for the set interface. What the internal implementation of set ensures is that there are no duplicates. Even if you have null in your set, then there can only be one null value. The way we added different elements to our other collections, we can add elements to set as well using the add method. We can remove elements, we can get an element and replace elements, and we can do all the different things that we have seen up till now for the different collections that we've discussed. So let's say this is one of our sets and this is named A, and let's say we have another set B which has these elements. Now, if we draw a Venn diagram, which I'm sure all of you have seen at one time or another, and if we look at the intersection between A and B, what would be the numbers that would be in the intersection part? Both of these sets have 2, both of these sets have 7, both of these sets have null, and both of these sets have 9. So these would be in the intersection of A and B. The ones that are left would remain in this part of A, and the ones that are left for B would be in this part. If we are to find the intersection of A and B, in mathematics we usually denote it as an inverted U. The result of A intersection B would be 2, 7, 9, and null, and this would be a set. If we are to find the union of A and B, this is how we usually write it, and this would contain all the elements in A and B, but there would be no duplicates. So we will have 2, 4, 7, null, 5, 9, 1, 6, 8, and 10. In Java, if you want to find the intersection of these two sets, and if we initialize A as a set and B as a set, then what we can do is that we can use a method that is there in sets, which is retain all. So we can use retain all in this way. And what this does is it retains all the elements of A and B that are present in both of these sets, which essentially is the intersection between A and B. And if we do add all, what this would do is this would add all the elements of B to A. But since this would also return a set, that set would not have any duplicates. So all the duplicates would be removed and we will be left with the union of A and B. Sets have 3 different implementations in Java. There is hash set, linked hash set, and tree set. One important thing to note is that sets are not ordered, which means that the elements in a set do not maintain any order by default. And so we do not have any index for set. Sets do not have indices. But if we want to iterate through each of the elements of a set, we can use the for each method from the iterable interface. Also, you would remember that the iterable interface allows us to return an iterator over the collection. So we can also use the iterator method to traverse the collection when we define it as a set. A hash set does not have any order, so it does not maintain any order. A linked hash set maintains an insertion order, and tree sets maintain an ascending order. So linked hash set and tree sets are special implementations of sets, and in these special implementations, we can see some order of the elements. In Java, whenever you need to have a collection that cannot have duplicates, you should always use sets. And usually, the default set that we use is a hash set. That takes care of sets. Now we can move on to maps.